drew them. We need to talk a little bit about what standard position is when we are going to talk about our coterminal. When we graph our angles, we are always going to graph them the same way. If an angle is in standard position, if you draw your x and y axis, that means the vertex is at the origin. The initial side is going to be the positive x-axis. And then your terminal side can be anywhere else. So maybe look at something like this. But the key to be in standard position, you have to have vertex at the origin, initial side on the positive x-axis. So that is always how we are going to measure our angles. We know that if you're going around, this is 0 degrees, this would be 90 degrees, 180, 0 would be the same, it'd be coterminal with what? 360. And you could keep going around if you wanted, you know, if I just keep adding 90. These are called quadrantal angles. They're the breaks in the quadrants. So any angle on the x or y axis is called a quadrantal angle. So here's 0, 90, 270, 360, 180, those angles. All right. Any questions on that? So I just want to do some coterminal examples. We are always going to prefer to deal with angles between 0 and 360. If we have a negative angle, we want to get rid of it. If I have something bigger than 360, I want to make it smaller. So we will find coterminal angles if I give you anything bigger than 360 or smaller than 0. To do that, you're just going to add or subtract 360 until you get something between 0 and 360. So on this one, we would have to start by subtracting 360. So if we do that, that gives me 746. Is that small enough? No. So let's subtract 360 again. And that gives me 386. Is that small enough? Nope. So subtract one more time. And so the angle that we would use here would be 26 degrees. These are coterminal. If I asked you to graph the angle 1106 degrees, and it has a vertex here, standard position, so that's our initial side. How many times did this go all the way around? Subtracted 360 3 times, so it goes all the way around 3 times, and it ends at about 26 degrees. So if I asked you to draw this, you would draw your arrow going around 1, 2, 3 times and back to that. After, I think on today's homework it does ask you to draw a few of those. After today, if I wanted you to draw it, I would just have you draw the 26 degrees, not the whole thing. But just so you understand what that means is it just kept going around the circle 3 times before it got back to the 26. If I asked you what quadrant is that angle in, do you remember your quadrants? This is quadrant 1, 2, 3, 4. So if I asked what quadrant it ended in, you guys can answer that question. This one's in quadrant 1. Okay, for part B, negative 150. What would you have to do here? Add 360. And we get 210 degrees. Do I have to do anything else to that? Nope, it's between 0 and 360, so it's good. If I asked you to graph that, vertex here, positive x-axis, the negative means it went down. This would be like negative 90. This would be negative 180. We just need to stop at negative 150. So that would be a negative 150 degrees. What quadrant does that one end in? Quadrant 3, if I ask that question.
instead of 210?
They're the same. If you drew, I just was graphing the original and showing you that. If you graph 210, it would start here, so it'd be 90, 180, and 210. It ends at the same place. That's why they're coterminal. Does that make sense? So if I asked you to graph, it would just depend which one I asked you to graph, if I said the original or the coterminal. Okay, why don't you guys do C? Just find the coterminal angle for me. So you add 360 how many times? 2. You had to add it twice. And what'd you get for your final angle? 117 degrees. Okay, so you guys can find coterminal angles if needed. The last thing that I want to talk about is some conversions. You might have done things like this in your science classes before. Sometimes in here we are going to convert things because we're going to have different possible measurements and we want to get everything to similar units. So I just wanted to throw a couple sample problems at you now, and then we'll just keep adding on to these and doing some more throughout the semester. So a wheel makes 270 revolutions per minute. What do I mean when I say revolution? Full 360 degrees, all the way around the circle. Through how many degrees will a point on the edge of the wheel move in 5 seconds? So basically I've given you the speed and I'm wanting you to tell me how many degrees it's going to move. So there are different ways of doing this. Some people like to look at this problem and they can just type something in on the calculator and get the answer. My mind is more methodical and I like work to justify everything, so I'm going to write it all out, but you don't necessarily have to do it the way I do it. I start with what I know. This is 270 revolutions per means divide by minute. Or you could call that 1 minute if you want. I am trying to, first of all, change this to degrees. So I'm going to multiply by another fraction. I want to get rid of my revolutions. It's on the top, so if I want it to cancel, it goes to the bottom. So I'm going to put my degrees on top and my revolutions on the bottom. So what's the conversion? 1 revolution is equal to how many degrees? So I'm going to put 360 degrees on top and 1 revolution on the bottom. Right now what this would do is cancel out my revolutions. So right now my units are degrees per minute. Now I am trying to get just plain degrees. You notice I've given you this 5 seconds. So what do I have to do with my time? Change it to seconds. Minutes are on the bottom. If I want to cancel it, it needs to go on the top. And I'm changing it into seconds. So what's my conversion? 1 minute is 60 seconds. So now my minutes will cancel out. My overall question is just how many degrees. So I don't want degrees per second. I just want degrees. The other information is we have 5 seconds, so I'm just going to take this times 5 seconds, and I'm just going to say over 1. And that will cancel my seconds. So now we're just going to work through this. My only unit left is degrees, so my final answer will be degrees. So you do 270 times 360 times 1 times 5. And what do we have to divide it by? 60. Basically, you're just multiplying everything on the top, dividing by what's on the bottom. And I get the 8,100. If it makes more sense to you, you could do like an intermediate step. If you just multiply top, 270 times 360 times 1 times 5. On the bottom, 1 times 1 times 60 times 1. So I divided by 60, and that's how I got here. So it's 8,100 degrees. Why don't you guys try one like that? Have you guys done something similar before? Have you guys seen this method? Some of you have, some have not. If you need another way of reasoning through this, I'll be happy. If this confuses you, I can sit down and go through different options with you if this one doesn't make sense. There's your time. So we know we have 480 revolutions per minute. My question is just how many degrees? So I have to get rid of everything else, and I know that I'm going to travel for 2 seconds. So first, let's change to degrees. So we want to cancel revolutions. It goes on the bottom. We know 1 revolution is all the way around the circle, so that's 360 degrees. I have seconds, so I need to change my minutes. They're on the bottom, so I need to put them on the top to cancel. So 1 minute is 60 seconds. So those would drop. We're traveling for 2 seconds, so I'm just going to put that over 1, so my seconds would drop. So 480 times 360 times 2, and then you have to divide that by 60, so you get 5,760 degrees. Okay? That's the end of this section. Yesterday I gave you like 13 problems. You guys also have those written down. So the ones that I want to add to that, I left off with 69. So there's 6 more problems, and then I'm going to give you some time to work now. 2, we are talking about angle relationships in similar triangles. So we're going to start this today, finish it up tomorrow, and probably have some class time to work on the homework again tomorrow. The first piece that I really want to get through today is talking about all of those special angles that you had in geometry. Remember the scenario, you have 2 parallel lines cut by a transversal. So something like this. I'm going to draw this picture one time. I'm going to number my angles, and then we'll answer all these questions based on that. So draw your 2 parallel lines cut by a transversal. And I'm going to number my angles, and let's all make sure we number them the same. Your angles. Alternate means opposite sides. Interior means inside. So they're inside the parallel lines on opposite sides of the transversal. So inside, that would be like angle 3 and which one? 6. There's another set. It would be 4 and 5. Okay, what would be true about those measurements? Equal measures, or you could say congruent angles. Okay, alternate exterior. So alternate means opposite sides of the transversal. Exterior means outside the parallel lines. So that would be another set. What's true about those? Those are also equal. consecutive, so that means same side, interior. So in the parallel lines on the same side of the transversal, that would be 3 and 5, and 4 and 6. Would those have the same measurement? No. Think about what we know. We know 3 and 6 have the same measure, right? And we know that 5 and 6 make a straight line. That means they add up to 180 degrees, so they're supplementary. So what has to be true about 3 and 5? Supplementary. Corresponding angles, what are those? Same position. Okay, so if we think angle 1, it's above its parallel line to the left of the transversal, so it corresponds with angle 5. Angle 2 corresponds with angle 6. Angle 3 and angle 7. Angle 4 and angle 8. What would be true about those measurements? For E. Is this okay so far? Even if you haven't had geometry, if I lost anybody. What are vertical angles? Think about when you have an X, they're across from each other. So my vertical angles would be 1 and 4, 2 and 3, 5 and 8, 6 and 7. And what's true about their measurements? Those are equal as well. So all of these special scenarios are equal except the consecutive interior. Those add up to 1. Any questions about that? I'm going to, I think, use today to kind of get through the notes portion, and then we'll save examples for tomorrow. So I want to get down a few things about triangles before we move on. In a triangle, what do the angles add up to? 180 degrees. When I talk about similar triangles, what am I referring to? That's true.
Same ratio.
Their sides are proportional, and what's true about their angles? They're the same. So similar triangles have the same angle measurements, and proportional sides. for instance, let's say I gave you a triangle. And I told you this angle was 50 degrees, this angle was 70 degrees. What would this one have to be? 60, because it has to add up to 180. Okay, then if I had a similar triangle, the angles would have to be the same. We would still have 50, 70, and 60 are our angles. Now our side measurements, let's say they were 3, 5, and 8. In the similar triangle, they are proportional. So for instance, if I took this side times 2 and got 6, then this side would have to be 10. And this side would have to be 16. You know, if you do 3 over 5, that's the same thing as 6 over 10. They are proportional. We can set up ratios with those. Any questions about that? One more thing I want to touch on is classifying triangles. So we can classify triangles 2 different ways, by their angles and by their sides. So when I'm talking about the different types of triangles. If it is an acute triangle, what does that mean? So an acute triangle is one where every single angle measures less than 90 degrees. What is a right triangle?
It has a 90 degree.
One right 93 angle. You can't have 2 right angles, then it wouldn't be a triangle anymore. What is an obtuse triangle? Would it be possible to have more than one angle bigger than 90? No, because then it would add up to more than 180 degrees. So one angle more than 90 degrees. Do you remember how we classified based on sides? Do you remember those terms? Scaling, isosceles. Equilateral. So those are the terms we use with our sides. What's scaling? Right. No sides the same. They're all different measures. What's isosceles? And what about equilateral? 3 equal sides. Every side is the same. questions? That's really where I just want to stop for today. So if you have your homework done, you got a little free time. If you don't, you've got some time to finish that up. Tomorrow we will start with the examples on this. I don't have very many, and then you'll have time to work on it.